Hello everyone, we're going to go ahead and do section 6.7, solving linear equations. So as an overview, we've already done some work involving linear equations in our past sections, but now we're going to focus on specific properties that allow us to actually solve them. So for example, we can find the total price of an iPhone including tax, but what if we want to find the price before tax? This type of problem requires the ability to solve equations, which is the most useful skill in algebra. So over here we have somebody with a broken phone, and so they want to go ahead, they want to find the price of the phone before tax, and maybe also after tax. So using algebra, you can help to solve those types of equations. So solving basic linear equations. So we've already seen linear equations in two variables. That's your ax plus by equals c. But now we're going to look at linear equations in one variable. So we're making it a little bit easier in this case. So a linear equation in one variable is an equation that can be written in the form of ax plus b equals 0, where a and b are real numbers and a is not 0. So it's one very specific thing we have to define, that a is not 0. If a were 0, it'd be 0 times x, which would just be 0, and so it kind of defeat the whole purpose. So for example, we'd have something like 2x plus 3 equals 7, which you could rewrite to be in the form as above by subtracting 7 from both sides, which would give you 2x minus 4 equals 0. So you can turn it into the form that we see there instead, so that it equals 0. You can kind of make that happen when it comes to solving linear equations in one variable. And when two equations have the same solution set, or the set of all possible solutions, we call them equivalent equations. So for example, something like x minus 3 equals 0 and 6 minus x equals 3 are equivalent equations since their solution is x equals 3. So 6 minus 3 is 3, and 3 minus 3 is 0. So they're written differently, but they are the same solution. They both satisfy their solution there, and so we call those equivalent equations. So remember in our last section with 6.6, we talked about expressions. So remember, expressions just don't have an equal sign. So if you have an equal sign, that makes them equations. So if we look at this little chart here, an expression would be something like 5x plus 7. But an equation would be 5x plus 7 equals 15. It equals something, which makes it an equation. So 3x plus 4y plus 7, the equation could be something like 3x plus 4y plus 7 equals 10. So there's an equal sign in it and a number on the other side. An expression 8 plus 5, for your equation, that could be 8 plus 5 equals 13x in that case. An expression 4 times x plus 6, our equation, we can make that 4 times x plus 6 equals 20x minus 7. So your equation just has an equal sign, and your expression does not. So that's really the only main difference there, but we can solve equations the same way that we solve expressions. It's just that when it comes to equations, remember, you can't do something on one side without doing it on the other. So you just want to remember to do that. So moving forward still with solving basic linear equations, we have the addition and subtraction properties of equality. You can add or subtract the same real number or algebraic expression from both sides of your equation without changing the solution set. So by adding or subtracting the same number or same algebraic expression, if you do that to both sides of your equation still stays equal. It's just that you've moved things around, you've rearranged things, but the equation sign is still there, they are still equal. So in symbols, this would look like if A equaled B, then A plus C equals B plus C, same as A minus C equals B minus C. So since you've added or subtracted the same number, in this case C, or variable C, your equation was still equal. You just have to do it to both sides. Then we have the multiplication and division properties of equality. You can multiply or divide the same non-zero real number from both sides of an equation without changing the solution set. So very similar to adding or subtracting, the same things work for dividing and multiplying. So as long as you're dividing or multiplying by the same number on both sides of your equation, they do stay equal. So in symbols, this looks like if A equals B, then A times C equals B times C. And also A divided by C and B divided by C are also equal as long as C does not equal 0. If C is equal to 0, then you would divide by 0. You just can't have that. Can't do that. That would make it indeterminate. So all that being said, we can look at some of the boxes here on the right-hand side. So starting at the top, we have x minus 5 equals 9. We want to solve for x, so we want to get rid of that minus 5. And so to get rid of that, you want to do the opposite operation. So x minus 5, we add 5 to both sides to get rid of that minus 5. So x minus 5 plus 5 cancels itself out to give you just x, but then you've added 5 on the other side, which tells us that 9 plus 5 is equal to 14. So x equals 14. Then, very similarly, we have y plus 30 equals 110. We want to get rid of the 30, so we'll subtract 30 from both sides, giving us y equals 80. Then we have t divided by 6 equals 3. We want to get rid of the division of 6, so in order to do that, we will multiply by 6. The division and the multiplication of 6 cancel each other out, but then on the other side there you have 3 times 6, which is 18. So that gives us that t equals 18. Then the last one there, we have 5x equals 30. We want to get rid of the coefficient of 5. 5 is being multiplied by x, so you can divide to get rid of it. So dividing both sides by 5 leaves us with an x on one side, and 30 divided by 5 is 6. So we get x equals 6. So as long as you add, subtract, multiply, or divide the same number or expression to both sides of your equation, it does keep it equal. So you don't have to worry about your equation not working anymore or not having the same solution anymore. As long as you've made it equal on both sides, everything should relatively stay the same. So solving general linear equations. So simplifying, we have steps here for solving general linear equations. Number 1 is to simplify the expressions on both sides of the equation by distributing and combining like terms. We learned about that in our last section there. So we'll distribute anything that is being multiplied and needs to use the distributive property, and then combine any like terms that you see on the same sides. So no moving sides yet, just simplifying each side. Then step 2, you'll use the addition and or subtraction property of equality to move all the variable terms to one side of the equation and all of your constant terms to the opposite side of the equation. So you want all of your terms that have a variable like x on one side, and everything that doesn't have x goes on the other side. Then step 3, you'll combine any like terms that you have. Then step 4, you'll use multiplication or the division property of equality to eliminate the numerical coefficient and solve for your variable. So we'll look at an example here. We have 5x plus 9 equals 29. So both sides are simplified. There's no need to distribute or combine like terms, so step 1 is not needed. Step 2, you want to use addition or subtraction to move all of your non-x terms to one side and your x terms to another. So we already have 5x on the right-hand side, but let's go ahead and move that 9. So we'll move the 9 by subtracting 9 from both sides, which leaves us with 5x equals 20. Now there's no terms that we need to combine, so step 3 is not useful here. But then step 4, use the multiplication or division property of equality to eliminate the numerical coefficient and solve for your variable. So you have 5 in front of the x, so you have 5x equals 20. You want to get rid of that 5 by dividing by 5 on both sides, leaving you with x equals 4. So we get that x is 4, or the solution set is 4 with the curly braces around it. So since you solved for x and you got a single answer there, you can always check your answer by plugging it into the original. So we had 5x plus 9 equaled 29. Now we're plugging in 4 for x, so we get 5 times 4 plus 9 equals 29. 5 times 4 is 20, plus 9 is 29. And so we get that 29 equals 29. That is correct. That is true, which means that yes, x equals 4 is the correct answer. So we're going to go ahead, we're going to do an example together. We're going to solve each of the following equations. A, we have 3 times 2x plus 5 minus 10 equals 3x minus 10. Then B, we have 2x minus 3 divided by 3 plus 5x divided by 2 equals x divided by 2 minus 4. So we're going to solve each of the following equations, which we're going to do in our notes. All right, so starting with part A here, we have 3 times 2x plus 5 minus 10 equals 3x minus 10. So starting with step 1, we are going to use our distributive property. We're going to combine any like terms that we need to in order to solve our problem. Now the right-hand side of our equation, 3x minus 10, that's already as simple as it goes. You can't combine any like terms that way. So now we're looking to the left. And the left definitely has things that we need to simplify and combine. So using our distributive property, we have 3 times 2x, so we'll multiply. And then we'll multiply 3 by 5 as well. So we'll get 3 times 2x plus 3 times 5. And then we're still subtracting 10, and this is still equal to 3x minus 10. So we'll simplify our answers here. We're going to multiply 3 times 2x, which gives us 6x, and 3 times 5 is 15, minus 10, and this is equal to 3x minus 10. And now combining any terms that we can, 15 minus 10, that's going to be 5. So this will give us 6x minus 5 is equal to 3x minus 10. All right, so that was step 1. Step 2 is to rearrange our equation. We're going to make sure that all of our x's are on one side and all of our constant terms or our numerical terms are on the other. So let's start off with getting rid of our minus 5 from our 6x minus 5. In order to do that, we will add 5 to both sides. So once we add 5, that will cancel, which leaves us with 6x equals 3x. And negative 10 plus 5 is going to be negative 5. So we'll write minus 5. Now we want all of our x terms on the opposite side, so we're going to make that the left side. So we're going to get rid of our negative 3x over here on the right and subtract from the left. So it cancels on the right. And 6x minus 3x is going to leave us with 3x there. And hopefully if you caught my mistake, great job. If not, I just caught it. So up here, when I did 15 minus 10, I said that that was negative 5. That is not correct. That is positive 5. So that was my mistake. It was just, you know, a little quiz for all of you. So that means that instead of adding 5, we're going to subtract 5. And negative 10 minus 5 is going to give us negative 15. So that is a negative 15 right there. Sorry about that. And so now that we've subtracted our negative 3x from both sides there, we have 3x equals negative 15. There we go. That looks a lot better. So we have 3x equals negative 15. Step 3 was to combine any like terms. We don't have any of those at this point. That's technically what we did above there. But so our last term is to just solve for our variable. We are multiplying x by 3, so in order to get rid of that, we'll divide both sides by 3, which will cancel our 3 there on the left. Then we're going to take this up over here to just write our last step there. We get x is equal to negative 15 divided by 3, which we can simplify to negative 5. And so for this one, our answer here is negative 5. And now we can always check our answer as well, just to do a little quick check. So you can check your answer by plugging it into the original. So we would have 3 times 2 times negative 5 plus 5 minus 10 is equal to 3 times negative 5 minus 10. And so we can just simplify this. So 2 times negative 5 is going to be negative 10 plus 5 minus 10. And 3 times negative 5 is negative 15 minus 10. Now, negative 10 plus 5 is negative 5, so we have 3 times negative 5 minus 10. And negative 15 minus 10 is negative 25. So 3 times negative 5 is negative 15 minus 10, which we're still saying is, questionably, a lot of the time when we check, we write like a little question mark, questionably equal to negative 25. And negative 15 minus 10 is negative 25, which is equal to negative 25, which means that checks out, which means your answer was correct. All right, so there we go. That was part A. So let's go on to B. Now B is a little bit trickier. We have a lot of fractions. That always makes problems harder. And so one of the best things that we can do whenever we have an entire equation or expression or anything, all in fractions, or even just one of them in fractions even, if we have fractions at all, the easiest thing to do is in your very first step is to just get rid of the fractions. We call this clearing the fractions. Fractions. This is a topic covered in Math 20, so if you do not quite remember, then you can go over and study up on that topic. So clearing the fractions in a quick way, in order to clear fractions that you have, you want to multiply it by the least common multiple of your denominators. So in our first portion there, 2x minus 3 over 3, the denominator is the number in the bottom, so that is, the number is 3. Then for the second part, you have 5x over 2, so you have another denominator of 2. That equals x over 2, once again 2, minus 4, which doesn't have a denominator. Technically, it's 1. So you want to get your least common multiple of your denominators. So least common multiple, a really good way to get your least common multiple, or at least a multiple that will work, is to multiply them together. So 3 times 2 is 6. That's going to be your least common multiple. Multiplying them together doesn't always give you the least common multiple. Sometimes it's not the least. It still works, but identifying the least common multiple is going to be the best way to do it. So clearing the fractions, we find the least common multiple of our denominators 3 and 2, and that is 6. So to clear the fractions, we're going to multiply every single part of our equation by 6. So that means that we'll have 6 times 2x minus 3 over 1 plus 6 times 5x over 2 is equal to 6 times x divided by 2 minus 6 times 4. So you'll multiply every single term by 6. That is not a 1. That's a 3. There we go. So we multiply every term by 6, and then we can multiply them together. And then we can simplify as much as we possibly can. So whenever we multiply by a whole number is the same as that number divided by 1. So this 6 is really 6 over 1. For the last one, 6 times 4, that's 24. We don't need to write 6 over 1 for that one, but it can help us multiply the rest of the fractions. So this will give us 6 times 2x minus 3 all over 3 plus 6 times 5x divided by 1 times 2 is 2. That's equal to 6 times x divided by 1 times 2, which is 2, minus, and then we got 24. So then we simplify as much as we can. So 6 divided by 3, we see here that we have our coefficient and our denominator. So we can divide those numbers out. So if we divide 6 by 3, that leaves a 2, and 3 divided by 3 is a 1. And then we do the same thing for 6 and 2 here. So 6 divided by 2 is 3, and 2 divided by 2 is 1. And then same over here, 6 divided by 2 is 3, and 2 divided by 2 is 1. And so changing all of our denominators to 1 essentially cancels out all of our denominators. So now we're left with 2 times 2x minus 3 plus 3 times 5x is equal to 3x minus 24. And now we no longer have any fractions within our equation. So now that we've done this, we can go ahead and kind of start with those 4 steps in order to solve a linear equation again. So clearing the fractions just kind of helps you get to that first step of solving a linear equation just a little easier. And so it's always a handy tool to kind of have in your back pocket. If you have an equation that has a lot of fractions, you just get rid of the fractions kind of as fast as possible so you don't really have to deal with them. And then you can go ahead and solve for your final answer a little bit easier. So we'll go ahead and we'll start from where we left off here. We're going to use our distributive property. We're going to multiply our 2 in here. Now we can multiply them right out. We don't have to write the extra step of 2 times 2x minus 2 times 3. You can if you are more comfortable with doing that. I strongly encourage it, but you don't have to. So we can multiply these and then just write the next line. So 2 times 2 is 4, so this will be 4x, 2 times 2x. The operation is going to stay the same in the middle, and 2 times 3 is 6. So we get 4x minus 6 plus 3 times 5x is 15x. And then this is equal to 3x minus 24. So now we want to take our step 2 here and combine our like terms on the same side. So on this side, our like terms are 4x and 15x. So we'll go ahead and combine those. So 4x plus 15x is going to be 19x. And this is minus 6 is equal to 3x minus 24. So we want to combine as, we want to get all of our x terms on one side and our non-x terms on the other. So we're going to go ahead, let's get rid of the 6, our non-x term, bring that to the other side. So we'll add 6 to both sides. That will cancel out over here. We get 19x is equal to 3x. And negative 24 plus 6 in that case is going to be negative 18. And then we want to bring our x terms over all to the left. So we'll subtract 3x from both sides, canceling it there on the right. Then we're going to bring this up over here. So 19x minus 3x is 16x is equal to negative 18. So step 3, to combine anything, any like terms on each side now. There's no need to. So moving on to step 4, we will solve for x by, multiplying or dividing our coefficient in front of x out. So we get x by itself. So we'll divide both sides by 16, canceling it on the left. And we'll get x is equal to negative 18 over 16. Now, our answer is a fraction. This is not too surprising considering our original equation had a lot of fractions in it. So having our answer as a fraction is okay, but we want to make sure it's the simplest fraction as possible. So 18 and 16, those are both divisible by 2. So what we can do is kind of write them out, expand them out a little bit. So negative 18 is the same as 2 times negative 9, and 16 is the same as 2 times 8. Our 2's can cancel because, we're being divided here, and then all that's left is negative 9 over 8, which is now not able to be simplified any further, which means that it's in its most simplified form. So x is equal to negative 9 over 8. Now, if you'd like, you can always check your answer by plugging x back into the equation, which I encourage you to do as an independent activity, to just check your answer. All right, so this is our answer here, -9/8. And so we finished off that example. So let's go ahead and go back on over to our lecture. Now we're going to do another example. We have the formula f is equal to 9/5c. That c is being multiplied by the fraction 9/5. C is not in the denominator in this case, just to clarify. Plus 32 gives the Fahrenheit equivalent for a temperature in Celsius. We're going to transform this into a formula for calculating the Celsius temperature C. So the formula is already solved for F, where C is in the equation. We're going to reverse this by solving our equation for C. So let's go ahead and go to our notes in order to do this. So here in our notes, we see that 9/5c plus 32. So we can just rewrite this. Just rewrite this here. So we have f is equal to 9/5 times c plus 32. And we're trying to solve for c. So this is the number here that we want isolated. We want c by itself. So we can even make a little note of that up here. Solve for c. So if we want c by itself, we need to get rid of all the things that are happening to c. So for example, we're adding 32. So in our steps for solving a linear equation, we went through and we don't need to do anything from step 1. There's no need to distribute anything or combine like terms. But step 2 is to make sure to kind of isolate what we're trying to solve for. You know, put all your x's on one side, all of your non-x terms on the other. Now in this case, we have f and c, so it's not exactly x, but we are trying to solve for c, so we're trying to get rid of everything that's happening to c. So we'll start by getting rid of 32. So we'll subtract 32 from both sides. It will cancel here on the right, but f minus 32, that pretty much just stays like that. There's really nothing to really do about it. And then this is equal to 9/5 times c. Now we're trying to solve for c, and when we try to solve for something, typically we really like it to be on the left. And currently c is on the right. Now a really good thing about an equation sign is that it's saying that both sides of this equation are equal to each other. So really, we can switch the sides whenever we want. So we're going to make a note of that. You can switch the two sides of an equation whenever you want. They're still equal. So we're going to switch our equations, or switch the sides of our equation here, just so we can have c already on the left. So when we solve, it's already on the left. Then we have f minus 32. So you can do that whenever you like. So if you want to do it at, at the end, you can do it at the end. If you want to do it the first moment you notice you'll want something on the other side, you can do it then. But since they're equal, you can switch them anytime that you want. They're still equal even if they're switched. So we've got our 9/5c is equal to f minus 32. Now we really want to get rid of the 9/5. So in order to get rid of that, you do have two options. There's one that's a little bit longer and one that is a little bit shorter. Now to get rid of a fraction, what you can do is multiply each side by its reciprocal. The reciprocal being the fraction that you have, just with the numerator and denominator switched. So our reciprocal of 9/5 would be 5/9. And multiplying a fraction by its reciprocal cancels the fraction out. They cancel each other out. So we could finish this problem in one step right now by multiplying each side by the reciprocal of 9/5, which is 5/9. So that is one option that we can do. We're going to show that option, then we're just going to show the other option just really quick. The answers are the same, even if they look a little bit different. So we can get rid of our 9 over 5c by multiplying both sides by the reciprocal 5 over 9. So that automatically cancels our fraction there. And we end up with c is equal to, and we're going to just move that fraction to the front, 5 over 9 times f minus 32. So that is one way in order to solve an equation that looks like that. When you have a fraction coefficient, multiplying each side by the reciprocal works pretty well there. We don't need to simplify 5/9 times f minus 32, although you could if you wanted to. But so another option here, so this was option 1. This is option 2. So when you have 9 over 5c is equal to f minus 32, you could get rid of the fraction a little slower, and that is to just kind of piece by piece kind of dissolve the fraction. So you're dividing by 5 on the left side there. So what you could do is you could multiply both sides by 5. And that will cancel out the 5 there on the left. That will leave you with 9c is equal to, and now you can distribute that 5 if you want, 5f minus 32 times 5, which is 160. And then you have 9 times c. We want to get rid of the 9, so we'll divide both sides by 9. Getting rid of that on the left there. And we get c is equal to 5f minus 160 over 9. And there's no need to simplify that function there. 5 divided by 9 is not going to simplify. 160 divided by 9 is not going to simplify. So it's probably best to just leave it as 5f minus 160 over 9. Now both of these answers, option 1 and option 2, they are the same. They are equal to each other. If we multiply that f minus 32 into the numerator of 5 over 9, it would give us the answer for option 2. So they're both correct. If you liked one more, if one felt more natural to you, then by all means use that one, or whichever one you want. The answer was still the same either way, so it truly didn't really matter which option you chose. But there we go. That was our second example there. So let's go ahead and go on back to our lecture. So now we have contradictions and identities. So a contradiction is an equation with no solution. So the solution set of a contradiction is the empty set, the curly braces with nothing in it, or the symbol for the empty set, which is a circle with a slash through it. So a contradiction just means that an equation that you have set up does not have a solution to it. An identity is an equation that is true for any value of the variable for which both sides are defined. So in a case like that, the solution would be something like x, where x is a real number. So let's look at two examples of this. So starting off with a contradiction, we start with the first box there on the right. We have x equals x plus 1. Now, in order to try to solve this equation, we want to get all of our x terms over on one side and our numerical terms on the other. So we could do something like subtracting by x on both sides to get rid of the x that's on the right. When we do that though, on the left we have x minus x, and that's 0. And x minus x plus 1, x minus x is 0, plus 1 is 1, and you end up getting this equation 0 equals 1, which is not true. That is a contradiction. That means that the equation that you solved for does not have a solution. So that would be a contradiction in that case. Now, an identity would be a similar type of problem where you would simplify as much as you could, but your variable would go away. It would go away in the same way it did for the contradiction, but your numbers at the end will be equal instead of different. So for example, we have 2 times 5x plus 8 minus 10 is equal to 10x plus 6. So distributing our 2, we get 10x plus 16 minus 10 equals 10x plus 6. So 16 minus 10 is 6, so we get 10x plus 6 equals 10x plus 6. This should be a hint at this point. It is the exact same equation on both sides of the equal sign. That is a true statement, that is equal, but when we go to try to solve, we see some things cancel. So if we want to bring all of our x terms over to the left, we could subtract 10x from both sides, but once we do that, 10x minus 10x is 0, which leaves us with a 6 on the left, and 10x minus 10x leaves us with, oh, there's an x missing there, but it's 10x minus 10x leaves us with a 0 plus 6 on the right as well, and we end up with the solution 6 equals 6. That is true. 6 does equal 6, so that is an identity. So in that case, it doesn't matter what value of x is, it's always going to be true. So basically every value of x is a solution in that case. So that's the difference between a contradiction and a solution. A contradiction means there is no solution, and an identity means every value of x ever is a solution. So we also call that infinitely many solutions. So we're going to go ahead and do some quick examples together. So we're going to decide if the given equation is a contradiction or an identity. So starting with A, we have 3 times x minus 6 plus 2x equals 5x minus 18. So we'll start by distributing our 3. So we'll get 3 times x minus 3 times 6. And then everything else is the same, plus 2x equals 5x minus 18. So 3 times 6 is 18. So 3x minus 18 plus 2x is equal to 5x minus 18. So we'll simplify, we'll combine our like terms of 3x plus 2x to get 5x minus 18 equals 5x minus 18. So this is one really, really big hint right now. It's the exact same equation on both sides of the equation sign. So simplifying that more, we'll subtract 5x from both sides, which leaves us with negative 18 equals negative 18. That is a true statement. So yes, that result is true. This is an identity, and our solution set is x, where x is a real number. So A is an identity. Now going on to B, we have 6x minus 4 plus 2x is equal to 8x minus 10. So we'll start off by simplifying any like terms. So 6x plus 2x can be combined to get 8x minus 4 is equal to 8x minus 10. Now let's go ahead and get all of our x terms over on the left, so we'll subtract 8x from both sides. And when we do that, our 8x's cancel out, which leaves us with negative 4 equals negative 10. That is not a true statement. Negative 4 does not equal negative 10. So since the result was false, this is a contradiction, and the solution set is the empty set, the circle with a slash through it. So there we go. We figured if each equation there was a contradiction or an identity. And that wraps up section 6.7. So in section 6.7, we learned how to identify linear equations, solve basic and general linear equations, solve formulas for a specific variable, and decide if an equation is an identity or a contradiction. So that wraps up section 6.7, and I'll see you in the next one.